Welcome, folks. We're going to talk about Coulomb's law today. Coulomb's law is an incredibly important mathematical relationship that talks about the force between two charged particles. And we're going to use that in chemistry to explain the behavior of proton-electron interactions within a atom, with ion-ion interactions in an ionic compound, between protons and electrons and covalent bonds, and lots more things. So there's lots of places where we're going to need to use Coulomb's law. So let's make sure you understand what it says as we get started. The mathematical expression for Coulomb's law is F equals K Q1 Q2 over R squared. And so what we're talking about here symbolically is F is the force between two charged particles. And that force is going to be felt by both of those charged particles. If those charged particles have the same sign, so they're both positive or they're both negative, this force will be repulsive. If, on the other hand, the charge on those particles are opposite, one is positive and one is negative, that force will be attractive. So that force has the symbol F, and formally it is going to have units of newtons. However, we're not going to be mathematically solving for that force, so we will rarely have an actual value that is going to be a number with the unit newton on it. K is a constant, and since we're not solving for it mathematically, we're not going to worry too much about what the value for that constant is. What's important is the rest of this expression, that Q1 Q2 over R squared. So as we look at the numerator of this equation, we have Q1 and Q2. That's the magnitude of the charges on our particles. So if either Q1 or Q2 or both of them becomes larger, becomes a more highly charged particle, then the force between them is going to increase. Conversely, if those charges become smaller, then you are going to have a decrease in the force experienced by those two charges. The denominator of this equation is R squared, and R is the distance between those two charged particles. And since R is in the denominator, if that distance becomes larger, that force is going to decrease. Those particles will interact less. However, if that distance becomes smaller, then you're going to have a larger force. And you need to note that R is squared, so that change in the distance has a very, very strong impact on the force experienced by two charged particles. So, in summary, like charges will repel and opposite charges will attract. If the magnitude of the charges becomes larger, there will be a greater force between them. If the distance between the two charges becomes larger, the force will decrease. If the distance is smaller, that force will increase. And as I mentioned, in this chemistry class, we're going to be using Coulomb's law qualitatively. You do need to memorize it so you can explain why increasing the charge or decreasing the distance will have an impact on the interactions between two particles, but we're not going to be doing calculations plugging in values for Coulomb's law. So while I gave you the value for that constant, it's not a number we're actually going to be using regularly. Instead, you need to be able to explain in terms of Coulomb's law why different changes has an impact on chemical properties.